Hi everyone, Miss Vasega here, and welcome to your last few days of physics. How the next few days are going to work is we've picked out several topics based on your interests that are weird, that don't fit in nicely into the normal physics curriculum. We've also picked topics where we don't actually know the answers to these questions, but thousands of scientists are currently working on them. We expect at some point in your lifetime, you're going to be reading about discoveries in these fields in the newspaper or whatever the equivalent of a newspaper looks like 15, 20, 30, 40 years from now. So what I want you to do is we ended up taking these topics and compiling super short videos for them. The videos are going to have lots of information about this brand new topic, which will change every day, but in a short period of time. I definitely suggest some sort of notebook, note-taking, so that when you get to the Google form at the end, you have lots of those pieces at your disposal in front of you. Okay, so today's topic is dark matter, and it's broken up into 3 parts from 2 sources. Part 1 is how much dark matter is there in the universe? If it's only a little tiny amount, does it really even matter? Part number 2 is how do we know it's there? If it's dark matter, then how is it we believe that our evidence shows this exists? And finally, what do we think it is? What are our current scientific best guess so far? Okay, so think of those 3 questions as you watch the next video, and best of luck, guys. Have a great week.
Matter as we know it. Atoms, stars and galaxies, planets and trees, rocks and us. This matter accounts for less than 5% of the known universe. About 25% is dark matter and 70% dark energy, both of which are invisible. This is kind of strange because it suggests that everything we experience is really only a tiny fraction of reality. But it gets worse. We really have no clue what dark matter and energy are or how they work. We are pretty sure they exist though. So, what do we know?
The ancient Greeks had a great idea. The universe is simple. In their minds, all you needed to make it were 4 elements: earth, air, fire, and water. As theories go, it's a beautiful one. It has simplicity and elegance. It says that by combining the 4 basic elements in different ways, you can produce all the wonderful diversity of the universe. Earth and fire, for example, give you things that are dry. Air and water, things that are wet. But as theories go, it had a problem. It didn't predict anything that could be measured. And measurement is the basis of experimental science. Worse still, the theory was wrong. But the Greeks were great scientists of the mind, and in the 5th century BC, Leucippus of Miletus came up with one of the most enduring scientific ideas ever. Everything we see is made up of tiny, indivisible bits of stuff called atoms. This theory is simple and elegant, and it has the advantage over the earth, air, fire and water theory of being right. Centuries of scientific thought and experimentation have established that the real elements, things like hydrogen, carbon and iron, can be broken down into atoms. In Leucippus's theory, the atom is the smallest indivisible bit of stuff that's still recognisable as hydrogen, carbon or iron. The only thing wrong with Leucippus's idea is that atoms are, in fact, divisible. Furthermore, his atoms idea turns out to explain just a small part of what the universe is made of. What appears to be the ordinary stuff of the universe is in fact quite rare. Leucippus's atoms, and the things they're made of, actually make up only about 5% of what we know to be there. Physicists know the rest of the universe, 95% of it, as the dark universe, made of dark matter and dark energy. How do we know this? Well, we know because we look at things and we see them. That might seem rather simplistic, but it's actually quite profound. All the stuff that's made of atoms is visible. Light bounces off it and we can see it. When we look out into space, we see stars and galaxies. Some of them, like the one we live in, with beautiful spiral shapes spinning gracefully through space. When scientists first measured the motion of groups of galaxies in the 1930s and weighed the amount of matter they contained, they were in for a surprise. They found that there's not enough visible stuff in those groups to hold them together. Later measurements of individual galaxies confirmed this puzzling result. There's simply not enough visible stuff in galaxies to provide enough gravity to hold them together. From what we can see, they ought to fly apart, but they don't. So there must be stuff there that we can't see. We call that stuff dark matter. The best evidence for dark matter today comes from measurements of something called the cosmic microwave background, the afterglow of the Big Bang, but that's another story. All of the evidence we have says that dark matter is there and accounts for much of the stuff in those beautiful spiral galaxies that fill the heavens.
Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex structures. Stars would more likely be scattered all over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby, so we know there's something there that interacts with gravity. We know dark matter is not just clouds of normal matter without stars because it would emit particles we could detect. Dark matter is not antimatter because antimatter produces unique gamma rays when it reacts with normal matter. Dark matter is also not made up of black holes, very compact objects that violently affect their surroundings, while dark matter seems to be scattered all over the place. Basically, we only know three things for sure. 1. Something is out there. 2. It interacts with gravity. 3. There is a lot of it. Dark matter is probably made up of a complicated exotic particle that doesn't interact with light and matter in a way we expect, but right now we just don't know. So there are still a lot of questions to answer. Our theories about dark matter and dark energy are still just that, theories. On the one hand, this is kind of frustrating. On the other hand, this is frontier science, making it very exciting. It shows us that no matter how much we feel we're on top of things, we're still very much apes with smartphones, on a tiny, fragile island in space, looking into the sky, wondering how our universe works. There is so much left to learn, and that is awesome.